You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Well, hello, everybody. Welcome back.
Hey.
Good to see you.
Good to be here.
My discussion a couple of weeks ago about the origin of life on Earth and all those chemicals necessary for life kind of got me thinking.
That existential crisis that was. Yeah.
It got me thinking about organisms that can survive in extreme environments, like the early Earth.
Okay.
Like extremophiles.
Extremophiles, exactly. Yeah. So that's what I want to talk about this episode.
Ooh.
So a little definition first. Extremophiles are considered to be organisms, usually bacteria and archaea, that live in extremes of temperature or salinity or pH, radiation, pressure, and energy or nutrient limitation, or some combination of several of those.
Makes sense.
And actually, up until 1969, the existence of extremophiles wasn't even known. It was thought, it was thought that bacteria could only really thrive in environments that were pretty similar to those that other life forms survive in. So
I would have thought it was like prior to that they had that kind of knowledge. That's interesting.
Right?
Yeah, it's relatively recently, right? And so it was thought that below about 60 to 70 degrees centigrade, that's 140 to 160 Fahrenheit, it was thought that nothing could survive. But in 1969, a paper was published by a microbiologist named Tom Brock, revealing his discovery of a bacterium that he found thriving in a Yellowstone hot spring.
Oh, gosh. I was just thinking about Yellowstone, while you were talking about that, because I was just there. Okay.
Yeah, at temperatures above 77 degrees centigrade. And he named it, a very appropriate name, Thermus aquaticus, meaning hot water. Basically.
That one's a real stretch.
Ooh, yeah. Wonder what it could be.
Well, you get there first. You get to get the good names.
Yep.
So that discovery really opened up a whole new area of research within microbiology and eventually led to the discovery of archaea, which originally were thought just to be a type of bacteria. And, they look like bacteria. They're single-celled microorganisms. They don't have a nucleus. But it turns out that based on some things like the composition of their cell wall and their genetics, they are in a totally different domain of life than bacteria. So just to kind of give you a sense of what that really means, there are three domains of life. There is the archaea, the bacteria, and the eukarya. And eukarya includes everything from foxes to mushrooms to birch trees to malaria parasites. So
I'm having flashbacks to when I talked about prokaryotic life.
Yeah.
All right, go for it.
Yeah, so the bacteria and the archaea are both prokaryotes, but they're completely different kinds of prokaryotes.
Right, right.
Yeah. So they look similar, but actually not bacteria, not even close. And many archaea are actually extremophiles, as well as different types of bacteria. So this is going to be one of those listicle episodes where I'm just going to talk about a bunch of weird places that bacteria and archaea can live. I feel like this is sort of a Kirk special kind of thing, but I'm going to do it this time.
Maybe that's why I love it.
Excited.
Yeah.
So just calling back to some of the ones we've talked about in previous episodes. Way back in episode 18, Kirk, you talked about a bacteria that lives all on its lonesome 2 miles down in gold mines and survives based on the products of radiation down there.
Oh, that's one of the weirdest topics I've done. Yeah, so
that's
crazy.
Bizarre, yeah. Oof.
I've talked before about the chemosynthetic bacteria that form the base of the food chain at deep sea hydrothermal vents. And some of the bacteria there can survive at high pressures, bottom of the ocean, and temperatures up to 122 degrees centigrade. That's well above the boiling point of water.
Ooh.
Just for you folks keeping track at home. Yeah. And those Yellowstone hot springs that were the source of Tom Brock's discovery of Thermus aquaticus, there have been many other species discovered at Yellowstone since then. They survive at various extreme levels of heat and acidity. Bacteria have been found living in the calderas of volcanoes. Some of the most acidic places on Earth are the outflow from mines. There's acid mine drainage, and bacteria live in that.
Oh, yeah.
The pH can be as low as 1, which is sulfuric acid.
Yeah. And they're like, oh, this is so nice.
This is pleasant.
Little sulfuric acid bath.
Just wanted to be soapy
cleansing
today.
Yeah.
It's cleansing at the end of the day. Yeah.
Ugh.
And to go to the other end of the pH scale, there are, of course, bacteria that also thrive in highly alkaline environments like soda lakes, for example. Some of these can live at pHs up to 12, which is somewhere between an ammonia solution and bleach.
Right.
Yeah.
Okay.
So, not too comfortable for us either, but they love it.
Not too comfortable is like the most gross understatement you could possibly make. Yeah.
I'm pretty sure it's the definition of grossly uncomfortable.
Yeah. Fatal. Yeah. Okay, good.
There are microbes that live in the coolant water at nuclear power plants, so very high levels of radiation.
Okay.
Obviously, we've talked about things that can survive in the vacuum and radiation and extreme temperatures of space. There are many bacteria that have survived that. Once some scientists sort of accidentally, they were doing some pressure experiments, they accidentally sort of amped up the pressure on some E. coli bacteria, which are normally found in our guts. And they squeezed them to a pressure of 16 atmospheres, and they survived.
Oh.
Did you say accidentally?
Yeah.
How do you do that by accident?
Right.
Well,
doesn't seem like.
I think they put the setting a little too high on the pressure squeezer in the lab.
Clearly. Wow.
Okay, there's more of a story there, but okay, go on.
Another episode, perhaps.
Yeah.
Not too long ago, I also talked about bacteria that survive in the extremely arid conditions of the central Atacama Desert.
Mm-hmm.
Yeah.
There's basically never rainfall, except, now climate change there is. But, and they think that's kind of like a suggestion that bacteria could survive there. It means they might be able to survive on Mars, for example. Scientists have extracted bacterial spores from the gut of a 40 million year old bee that was preserved in amber.
Nice.
And
That's some Jurassic Park level stuff right there.
Yeah, it is.
So bacterial spores are like, it's totally Jurassic Park level stuff. Bacterial spores are a kind of an extra hardy survival mechanism that some bacteria can do, where they basically remove almost all the water from the cell and just kind of...
Yeah, it's like cryptobiosis, like we talked about with the sea monkeys.
Yeah, exactly. And they were able to revive these bacterial spores, and then they reproduced.
Seems
like the start of some kind of outbreak movie.
Yeah, it does.
Yeah.
I'm like that. Have they watched? I know scientists who do that kind of stuff tend to watch those movies. They get a kick out of them.
Yeah.
Why?
They're like, this is so bad. This is not how it is at all.
Exactly.
Right. We hope.
And then they go and do it.
Yeah.
Ugh.
There are microbes that live in the Dead Sea and other extremely salty environments. And for some reason, this one I'm about to say is the one I found kind of the most surprising. I don't know why, but there are microbes that live in tar pits, like the famous La Brea tar pits in Los Angeles.
What?
Huh.
Okay.
Sure. That doesn't...
I guess.
I hadn't really thought about it, but it's not too surprising.
It just
I mean,
seems-
hydrocarbons and...
it seems like, I don't know, it seems like a more toxic environment than.
They are tar pits.
Yeah.
It's a lot to feed on, though.
Yeah, it's true.
Yeah.
There are
Something's
petroleum
gotta
eating
decompose
bacteria.
Right, yeah.
Yeah.
A lot of petrochemicals.
So that's quite a list. And, there's more that I didn't even cover. I didn't get into nutrient and energy limitations really, but the thing is, what I find so interesting thinking about this is that what we consider an extreme environment is really perfectly normal to the bacteria and archaea that live in these environments.
Yeah.
Right.
Yeah, and
we can't live there.
Yeah. And as I kind of alluded to in my previous episode, over the course of the Earth's history, extremophiles would have been probably the first life forms. And over the course of the Earth's history, these kind of extremophile organisms have been the dominant life form, most likely for big chunks of the Earth's history. So, it's really from a human perspective that we call them extremophiles.
Right.
They just call us
I
weaklings.
always find it funny when people try to make the argument that when they say, like, isn't it amazing that, like, the Earth is perfectly, like the perfect place for humans. And I'm like, no, that's backwards. Like
we
if it wasn't,
here.
we wouldn't be here. Yeah. But if it wasn't, like you're saying, if it was a much more, well, I was going to say hostile, but say a hotter place or a more acidic place, different forms of life would have evolved, and they'd be sitting around thinking like, man, how could life ever survive if it was like 70 degrees outside? Yeah. Isn't that crazy? It's like, nuts. That's just life finds a way, right?
It does.
Yeah, that's what I have. I want to give a shout out to a couple of sources that I drew from this week. One is a paper from April 2019 in Frontiers in Microbiology, and it's called Living at the Extremes, Extremophiles and the Limits of Life in a Planetary Context by Nancy Marino and her colleagues. And then a article from Smithsonian Magazine called Top 10 Places Where Life Shouldn't Exist But Does.
Nice.
That's a good title. I like that. That's a good one.
Yep.
Oh. All right. Well, we're going to have a little break. And when we come back from the break, Kirk will be up.
That's right.
Yeah.
Strange by Nature podcast is brought to you by listeners like you who have joined the Society of Strange, our membership group on over at patreon.com/strangebynature. Society of Strange members can join at one of 3 different membership levels and help support the show, and also get some fun stuff like water bottle stickers or access to super secret content. So thank you to those who have joined already to help make this podcast possible. If you haven't joined yet, we'll see you soon over at the Society of Strange at patreon.com/strangebynature. See you soon.
Welcome back. Like most of us, I was raised on a steady diet of terrifying German folktales, thanks to the Brothers Grimm. So we've got The Wolf and the 7 Young Goats. Spoiler alert, they get eaten.
Yeah.
There was also Little Red Riding Hood. Spoiler, Granny gets eaten. And then there's The Wolf and the Man, The Wolf and the Fox. Spoiler, the greedy wolf dies in that one. There's also another one in Brothers Grimm Tales, the Gossip Wolf and the Fox. And actually in this one, I feel kind of bad for the wolf because Fox plays a trick on her and she ends up having boiling hot lye water, like wash water, poured on her by peasants.
Oh my gosh.
Giving her like a terrible chemical burn while the fox kind of laughs at her.
Rude.
So did I mention these are German children's stories?
Yeah.
I'm sensing a theme with these.
I am too.
You are. So, in the Grimm brothers' defense, though, I will say that even back when their book came out, and they called them children's stories, a lot of people were outraged that they were too graphic for children. They did actually relent, and in one of the later editions, they removed a number of stories, including one called The Children Who Played Slaughtering. Which is not what I read as a child.
Played what?
Slaughtering.
Like
slaughtering. Like, yes. Slaughter, yes.
Oh my
murdering
God.
animals and disemboweling them. Yeah, I have to look it up. I didn't actually read that story. Now I'm kind of curious. But my point of talking about all that is that in nearly all the old stories told, and not just in Europe, but in many cultures, but not all of them, but in many cultures, the wolf is the bad guy in the story, right? So we humans seem to have a real talent for vilifying wolves, or at least just having them be tortured in stories. And so in these stories, the wolves aren't bad guys for doing what wolves actually do.
No.
Usually they're a proxy for the worst of human nature. And so we project our worst traits onto wolves.
Exactly.
So they're kind of a proxy for, like terrible humanity. But I think because it's so pervasive in our culture, even those of us who like wolves still have an image of them in our heads as like super fierce predators. And to be clear, they are amazing hunters and predators, but we probably over-exaggerate in our minds what a wolf is like because of a lot of the cultural representations of these like bloodthirsty animals, right?
Yeah.
So like, I mean, my little dear 30-pound dog, Ada, is the biggest snugglebug cutie in the world.
So cute.
But she also caught and bit the head off a squirrel the other day. So
Of course she did.
It seems strange to me that like we think of dogs as being mostly cute and snuggly when they're perfectly capable of doing these things, but somehow wolves are like vicious killing machines, right?
Exactly.
Now, the three of us all live in Minnesota, and one awesome distinction of our state is that while everyone else was busy successfully exterminating wolves from their states, we failed. Yay us.
Aha.
So at one point, aside from Alaska, Minnesota was, I believe, the only state in the the U.S., again, besides Alaska,
The continental
to still
US.
have gray wolves. Yeah, or timber wolves. Well, the lower 48.
Right.
Yeah, they weren't in Hawaii. Good point. So we're the only ones to have wolves left, aside from Alaska. It was estimated at one point there was only 350 wolves left in the state, but current estimates are that we have 2,700 wolves in Minnesota.
Cool.
So, by the way, Alaska does still have us beat because Alaska's huge.
Yeah.
They currently are estimated to have 18,000 wolves.
That is quite a bit more.
It's a lot. And I was curious about this, so I did some math. The human population of Alaska is only 737,000 people. So that is
I wasn't expecting
one
that
wolf.
1,000. I'm not gonna lie.
It's more than 737 people.
I know.
The what that works out to is one wolf to every 40 people, which is pretty impressive.
Nice.
We have far less wilderness here and far more people. The population of our state is 5.6 million people, which means there's one wolf for every 2,000 people. So quite a difference. I was just curious, Victoria and Rachel, have either of you ever seen a wolf in the wild in Minnesota?
I've never seen a wolf in the wild. I've seen them in captive contexts.
Gotcha. Rachel?
You're
up in wolf country now.
I am up in wolf country now. I'm with Victoria. I haven't seen one in the wild. I've seen signs though. Just the other day, we found some wolf scat. We're pretty sure it was wolf scat. It was very furry.
Excellent. Well, you mentioned wolf scat, and I was going to say that kind of ties into my story because we think of wolves as being ferocious meat eaters, but biologists wanted to better understand their diet. So they did something
I know
referenced.
what you're talking about today.
I referenced way back in an episode last year when I talked about learning more about the diets of mountain lions, and they did the classic move of studying that lovely substance that starts with an S and ends with a T, comes out of you, comes out of me. I know what you're thinking, but don't think that. We're scientists. We call it
Scat.
Exactly. So in 2017, a team of researchers at Voyageurs National Park in Minnesota did the dirty work of checking scat piles to figure out exactly what wolves were eating. And it turns out sometimes the answer is, surprisingly, berries.
I just learned this.
Specifically, sometimes raspberries, but here in Minnesota, mostly blueberries. Now, how many, you ask? Well, I actually found conflicting numbers, but in Minnesota in July and August, which is berry season, researchers believe blueberries make up somewhere around 30 to 50% of a wolf's diet.
That's a lot of berries.
And that's a lot of berries because they're really small. And I did find one source claiming it might be as high as 83% of their diet.
Yep.
But I didn't actually see that number backed up any actual research. It was just like a reference on a web page about wolves from a wolf group. So
I'm, by the way, bringing this back because we 100% have said 83% at the nature center that I work at.
Yeah, so I want to know where that came from because like the actual research papers I was reading were saying 30 to 50%. And then they'd reference the research paper and say it's as high as 83%. And you're like, that's not what the research paper says. So very curious where they're getting that number from. So I want to actually read a passage from the research journal article, which, by the way, is called Estimating Biomass of Berries Consumed by Gray Wolves. And this was in the Wildlife Society Bulletin in 2017. So here it goes. You ready?
Mm-hmm.
Scats were collected on trail and logging roads, at home sites, and at clusters of GPS locations. We transferred individual scats to nylon stockings and sterilized them by boiling in water for greater than 45 minutes. Yeah. We then washed the scats in a washing machine and allowed them to air dry for greater than 12 hours. So,
hold on.
I'm just really wondering, first off, whose stove and pot did they use to boil them in nylon stockings for 45 minutes? And what did that smell like?
That's just to sanitize. Oh,
I really hope that was done outdoors. I hope that was, they didn't say how fresh the scat was, but at that point, when you're going to rehydrate them, I'm not sure it really matters.
Yeah.
Although I know from a lot of the coyote scat we find on a day-to-day basis where I work, if they're really old, they're basically just piles of fur.
Yeah.
Right. So like, I think they were fairly fresh. This is lovely. So I was thinking about this and I'm like, secondly, I said, first off, what pot did they use? But also, secondly, whose washing machine did they use?
That's where I'm stuck here.
Right? Like, did they just stroll down to the public laundromat? Because that's not okay.
No.
And did they use like the staff one at a research station, which is probably way more likely? And yikes, I don't want to be the person washing my clothes in like the wolf scat washer.
No.
Right?
Did they buy one just for this? Did they maybe get
I
one?
doubt used one.
Maybe
you used one. There's ones that you can like attach into a sink now.
Yeah, I mean, look,
but also
TMI, but like when I had a baby at home, we were washing reusable diapers in the washing machine. So
yeah, but also why are they washing it in the washing machine?
Because they're trying to, I think, wash away microscopic organic matter, so they're just left with the seeds. Because what they're really looking at is how many blueberry seeds were in the scat. So that gets to why they're washing them and washing them in nylons. They wanted to be only left with seeds so they could do some counting. Okay. At first, when I heard about this, I figured some poor person had to sit there and count all the seeds, and each blueberry has around 14 seeds in it, and they're very tiny. It turns out they did not do that. They worked out this whole grid method of spreading them out and then averaging it and counting, like selecting a sample size from certain grids and then estimating how many was in the whole pile.
Okay.
That explains a lot, though, because I was thinking there was not going to be a lot left of the scat by the time it went through the boiling and the washing.
And they didn't want a lot left.
In fact, they just wanted the seeds.
So, like I said, they ended up not counting every single seed. Because there's 14 seeds per berry and the wolves had just gorged themselves on berries. But they used this estimation technique to find out how much they were eating. And the big reason they were doing this is so that future researchers can now use their numbers when counting scat piles instead of having to do the dirty work and befouling more washing machines and kitchen pots.
Right.
So they're trying to establish like a baseline for other future research. That's kind of what I wanted to talk about. It's really just that I find it fascinating to learn that this animal that we think of as such like an apex predator, right? And like it's so much like a carnivorous animal. People use it as their prime example of like, this is the carnivorous, beastie out there in the woods.
It is the big bad wolf.
Yeah, the big bad wolf, right? And it turns out in the summer, they're pretty much just content to sit around chowing down on berries. Now, berries are not as calorically dense as meat, so they probably do need to eat a little bit more of them, but also they're not really expending virtually any energy to get the berries. They just walk to the berry patch and eat them, and frankly, probably poop out the seeds there so the berry patch grows even bigger.
Yep.
So it's like, they spend very little energy getting this food source, and it's also incidentally a favorite food source of their pups. They're like actually feed kind of regurgitating it and stuff for their pups. So it's what a lot of the pups are eating when they're young. So I guess basically next time you're reading a grim fairy tale and there's a suspicious red liquid dripping off the teeth of the big bad wolf, just remember if it's July or August, there's a good chance it's just like raspberry jam.
Beautiful.
Right?
I love
That's
that.
great.
Yeah. So that's what I have for you this week. The fact that wolves are actually gorging themselves probably more than half of their diet in July and August is berries.
That's so
Surprise.
fun.
Wonderful.
Oh,
Yeah.
thanks, Kirk.
Sure thing. We're going to go to break. When we come back, it'll be Rachel.
Woo! Welcome back, everyone. Hope you had a nice break.
Oh, it was lovely.
Fabulous. I did the math, and this episode actually comes out is our first episode of June this year. So I decided to
Happy June.
Happy June. I decided to do something of a theme this month, of everything or anything rainbow for Pride Month.
Oh, yeah. Yay. All
Yeah.
right. Cool. Let's talk about rainbows.
Talk about rainbows. But to start us off, I wanted to talk about this. It's been on my list forever, and I'm honestly surprised we haven't talked about it yet. I'm talking about a creature that's not only brightly colored and has crazy adaptations, but can see more colors than we can.
Oh, yeah. It's on my list. I just hadn't gotten to it. we know exactly. I wonder how many listeners, like, when we do that and they're like, oh, I know what you're going to see, if they know where we're going, or if they're like, well, how do they know what they're talking about? Go for it.
So today I'm talking about the Odontodactylus scalarius, or the Peacock Mantis Shrimp.
Yeah.
Yeah.
So cool. Look it up. Check out our social media account or check
beautiful.
out the photos online.
Yes. It will
It's
be on
beautiful,
our...
and we probably don't even see how beautiful it truly is.
We don't, actually, and I'm going to talk about it.
Sweet.
So generally, the Peacock Mantis Shrimp is found in the Indian and Pacific Oceans. It likes really nice warm waters in like the shallows and like reefs. Loves being in the sand. And this 2 to 7 inch long critter is just nuts. Okay. First of all, just a riot of color. Like, its exoskeleton is very brightly colored. The females tend to be more red in coloration, but the males often have bright blues and reds and greens, and there's yellows. And they are shaped like a shrimp. So in your head, maybe think like a lobster. If you don't know what a real life shrimp looks like, not the shrimp cocktail that you might get. Think of like a lobster, but smaller. They have a really long abdomen, and it's pretty segmented. And they have at the bottom of that abdomen, or more where like it hits the ground, are these like furry looking legs. Some of the pictures
Right.
that I saw, like it's bright blue, and then surrounding that furry bit is, to be clear, not actually fur, but is like a deep, like very deep red, which is so cool. Now, personally speaking, you would think, or I would think, that the color would hurt the animal. Like, why would you evolve to be that brightly colored? You'd think that would lead to having more predators eat them, because there are animals that do eat the mantis shrimp. So it's like it kind of goes against.
So it would hurt
survival.
from a predatory standpoint, not like a, oh my God, these colors are so painful standpoint.
Exactly.
Just to clarify. Okay, good.
Yes. But they do actually burrow down in like U-shaped burrows in the sand. Those tend to be where they are, so that helps protect them. But also, they're pretty fierce. They
yeah, they are.
Yeah, so they pack a punch. How they hunt, they are active predators. They eat other things like other mollusks like crab and oysters and things like that. Not necessarily oysters.
Crabs and shrimp are crustaceans.
Yes.
Yep.
But it also eats mollusks as well.
Yes. Gotcha.
It can eat anything that's bigger than it. Actually, which is
anything?
Okay, not anything. It can eat a lot of things if it hadn't to be bigger than it.
I just picture like a blue whale, like, oh crap, it's a mantis shrimp.
Run away!
Run away! It's a big punch. It's not that big.
No.
Okay.
Remember, it's like a 2 to 7 inch long creature. Like it's
right.
Yeah. It still packs a punch though. So it has these front appendages that seem to always be like up in a boxer's like block. If for example, if it was a human, like your fist would be up near your face and your elbows punched and you'd be holding yourself in, like always ready to like punch or block or whatever.
Yeah, ready for a jab or something, yeah.
Exactly. And these are still brightly colored, but this is the fastest punch of any living thing on the planet. Mm-hmm. It is so fast. It's about 50 times faster than the blink of an eye. Scientists have clocked it at over 50 miles an hour.
Wow.
It has broken aquarium glass.
That's just nuts.
I've heard that. Yeah, they can actually break the glass of an aquarium.
Which,
wow.
Awful. Because that's special, pretty
it's
thick
also a
glass.
Mess.
It's a mess. But yeah. And that's
you hope that's tempered glass too.
You hope. And it's so fast that the punch itself will most likely kill the creature whatever it's trying to hunt. But it's literally so fast that it creates its own little air bubbles of sorts.
Yeah.
And where there was none. And when those bubbles burst, they actually change the temperature of the water when it's released to close to near the sun temperature. Like it's really, really hot.
That is so wild. Yeah, it's
so
called
cavitation
when you create bubbles like that. It's mind-boggling.
It's just it's punching so fast that it creates a vacuum of sorts. Like it's literally pushing the water at the bottom of the ocean away. It's nuts.
So wild.
Ugh.
It's hard to wrap your mind around it.
It really is.
Yeah.
You know, you're talking about the temperature of the surface of the sun from, I think it's the collapsing of the bubbles that creates the.
Yeah.
I can't remember. Yeah. I mean, it's like, now, did you read up this? Is this my imagination that it actually creates light as well? Like that, the collapsing or the cavitation that you can see like a little flash when they do it, if you have the right conditions?
I think in the right conditions it can.
Could totally be a dream I had. So
it might have been. I didn't see anything that mentioned it when I was doing my research.
Okay.
So we talked about all of those things, but I also really want to talk more about its shell, about its exoskeleton, because not only are they brightly colored, but mantis shrimp actually have like super complex eyes. Filled with not rods and cones necessarily, but like really specialized eyes,
Receptor
pretty much.
cells.
Yeah, receptor cells. And they are able to view wavelengths outside of the visual light spectrum. And because of this, their exoskeleton actually is even more elaborate looking outside of the visual light spectrum. Like the patterns and such that are on
Right.
are things that we can't see without special conditions and special light. So this little shrimp can see more than we are able to see, which I think is nuts. Just to think about an animal that, like, I can't even fathom seeing outside of the visual light spectrum.
Yeah, like what would a different color even? How would your brain
Right?
process
Like
that?
Yeah.
what would it look like to see UV ray or radio waves or things like that? What would that even look like? You know? And
Yeah, I mean, there's a whole. I may someday do like a whole episode on just the entire electromagnetic spectrum because it's we just think about the light, but there's so much more to it.
yeah, it's just absolutely insane, and I can't wrap my brain around it. And I would just want to do something super colorful, and they are quite literally called the peacock or the rainbow mantis shrimp. So I just want to talk about that today.
Yeah, they are
Such a cool creature.
probably one of the most beautiful, amazing creatures you'll ever see.
Mm-hmm.
And I did look it up by the way, and there are some things online claiming that you can see there is light that is given off sometimes, but the it's not that it's the heat like boiling the water, that it's actually I was reading it's a decrease in the pressure. Like when you lower the pressure, water boils at a lower temperature. So like that vacuum, like you talked about, that's what's causing the boiling of the little water. Like that's so wild. They are mind blowing.
They are. I want to know the pressures that caused it to be like a predator that just punches its prey. You know
what made it have to get that fast, or what's the versus slower?
Exactly. It would be really fascinating to find out what that evolutionary pressure was.
Absolutely.
Yeah.
Absolutely.
Well, that's all that I have for us today. Thanks for listening, and we'll see you next week.
Bye-bye.
Bye-bye.
Any bonus on
Thanks
that?
everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.